Hi, this is Jeline from the Honors Tutorial. Our topic for today is about principal roots of rational and irrational numbers. This is the part 2 of this topic. This is under Mathematics 7. So this is the continuation of the topic. So let's have this example. We have here the square root of 16 over 81. How are we going to solve for this kind of example or equation? This is how you're going to solve for it. Please have the numerator first. Okay? Look for a number that when you square is equal to 16. So what is that number? Is it 2? Let's try. 2 raised to 2 is 4. So it's not. Is it 3? 3 raised to 2 is 9. So it's not. Why is it 3? Why is it 9 again? It is because 3 raised to 2 means 3 times 3. It is because your exponent is telling you how many times are you going to multiply the base to itself. So that is twice. So please don't have 3 times 2 in your equation when you have 3 squared, okay? Next, since it is not 16, let's move to 4. We have here 4 squared. 4 squared meaning 4 times 4, not 4 times 2, okay? So it means 4 times 4. So that is 16. So therefore, we're going to get the base. So the base is 4. So our answer here for the numerator only is 4. Next, let's solve for the denominator, 81. So let's see if 7 will work. So 7 squared. 7 squared is 7 times 7, okay? It's not 7 times 2. 7 times 7 is 49. It's not 81, so let's continue. How about 8 squared? 8 squared is not 8 times 2. It is 8 times 8. 8 times 8 is 64. So therefore, it is not the answer yet. Let's have 9. 9 squared. 9 squared is not 9 times 2. It is 9 times 9. Again, it is because your exponent is telling your base how many times are you going to solve or multiply your base to itself, and that is twice. So 9 times 9 is 81. So we have the answer, but it is not 81, it's 9, the base. And this is it. That's the final answer. It's 4 over 9. So again, in solving principal roots of rational numbers in the form of a fraction, please solve it separately. Have the numerator first and then solve for the denominator. And then don't forget that you will only get the base, not the exponent. So that's it for this example. Let's have another. It's 49 over 100. So still the process is the same. Look for a number that when you multiply to itself or raise to 2 is equal to 49. Let's see if 6 will work. 6 squared is 6 times 6. So that's 36. It is not 49. So it is not the number that we are looking for. Let's say that it is 7. So 7 squared, it is 7 times 7. It's 49. So therefore, the answer is 7. Please don't include the exponent. So we have here 7 over 100. What is the square root of 100? Let's see. If 9 squared earlier, so that is 9 times 9 is 81, higher than 9. So it's 10 squared. So 10 times 10, that is 100. So therefore, the answer is the base, which is 10. So the answer is 7 over 10. Next, let's have another example. Let's have the principal roots of irrational numbers. Actually, for irrational numbers, we cannot find the exact principal root of it because if you will get it, it will become a decimal number. There is a separate lesson about it, but for this part, we are going to determine between what two consecutive integers does square root of 20 lies. So how are we going to do it? So you have to know what is, for example, 2 squared, 3 squared, 5 squared, and so on and so forth for you to master it. It is very important because we're just going to look if which number or in which number this number lies. I will show you. Let's list some numbers. So if we have here 1 squared, we have here 1. If we have here 2 squared, we have 4. If we have 3 squared, we have 9. If we have 4 squared, we have 16. If we have 5 squared, we have here 25. We don't have 20 here, so therefore we are going to look for two consecutive integers. So therefore, we are going to use the numbers which is the nearest to square root of 20, and that is 16 and 25. Because square root of 20 is in between 16 and 25. So therefore, this is how we are going to write it. Square root of 16, this number, will be written here at the left side. And then we will write square root of 20 in between. And then we are going to write square root of 25 here. And of course, we have to have our symbols. Square root of 20 is greater than square root of 16, which is true. And square root of 20 is less than square root of 25, which is also true. To find out in which integers does square root of 20 lies, we have to get the square root of 16. We will not experience any difficulty with it because we already have here the answer. That is the base. So we have here 4. Let me just write it here. And then copy the sign or the symbol here. And then copy square root of 20. And then have the sign again. And then square root of 25, just get the base, that is 5. So we can say that square root of 20 is greater than 4 but is less than 5. So therefore, your final answer will be this. So we can say that square root of 20 lies between 4 and 5. 4 and 5. So this is your final answer. Again, Square root of 20 lies between 4 and 5. Next, let's have another example. We have here square root of 180. Same process. So let's start with 12. 12 raised to 2 is 144. Let's say that we have here 13 raised to 2, that is 169. It is not yet 180, so let's have 14 raised to 2. That is 196. Okay, so it's too much. 196 is greater than 180, so we have to stop. So therefore, numbers that we are going to get are 13 and 14, these numbers. Because 13 is less than 180 and 14 squared is less than greater than 180. So this is how we are going to solve for it. Write 180 here at the middle and then write greater than. Yan. 180 is greater than square root of 169. This part only. And then 180, square root of 180 is less than this square root of 196. And then let's get the square root of 169. But first, let's copy square root of 180 again. And then square root of 180 is greater than 13, but is less than the square root of 196, which is 14. So therefore, for our final answer, we can say that square root of 180 lies between 13 and 14. So that is how we get principal roots of irrational numbers. Last example, negative square root of 90. So for negative square root of 90, don't worry, the process is still the same. The difference is just we have a negative number outside. So same process, let's start with 8. So we have here 8 squared, so that's 64. 9 squared, that's 81. 10 squared, that's 100. Let's solve. We're going to get this part. So we have here negative square root of 90 is greater than negative square root of 81. We're going to include it. And it is less than negative square root of 100. This is the usual way of writing it, right? But don't be confused. It is because we have here negative sign. So therefore, we have to interchange the places of 81 and 100. Negative square root of 81 and negative square root of 100. Because when it comes to negative numbers, those numbers that is the nearest to zero are the biggest or the bigger number. Okay? But those numbers that is not close to zero, those are less in value. So for example, we have here the square root, negative square root of 100. We have here negative square root of 81. Negative square root of 81 is bigger than negative square root of 100. Why? Because negative square root of 100 is not that close to zero as it is as close to zero for negative square root of 81. So therefore, we have to interchange their places. So usually we write it like this, but this is a negative number. So it will become negative square root of 90 is greater than negative square root of 100 and is less than negative square root of 81. See the transformation of the equation. And then after that, get the square root of 100. That's 10, the base. So we have here negative 10. Just write the negative sign. Don't be bothered about it. Just copy it. Then copy the symbol and then just write negative square root of 90. Symbol again. Then write the negative sign. Then get the square root of 81. That's 9. So therefore, we can say that negative square root of 90 is less than negative 9 but is greater than negative 10. Again, if we are going to look at the number line, this is 0, this is negative 9, this is negative 10. That's why 9 is bigger than negative 10. Negative 9 is bigger than negative 10. It is because 9 is closer to 0 compared to negative 10. That is the concept of negative numbers. If you are closer to 0 than the other number, then you are the bigger number. Okay? So therefore, the final answer here is this. Negative square root of 90 lies between negative 10 and negative 9. So that's it for principal roots for rational and irrational numbers. If you have inquiries about this topic or about us, the honors tutorial, kindly message our page. And thank you and God bless. Bye.